What's up, you math nerds? Hope you're having a fabulous day, morning, or afternoon from wherever you're joining. My name's Miguel, also known as the Vegan Math Guy, and you probably have seen a lot of my TikToks lately because I've been posting religiously about the AP exam, and I'm so excited that we have the AP Calc AB FRQ in front of us. So we're going to do a couple of the problems. As I mentioned, I will post or I will solve these the way I thought they would be solved. If I'm incorrect, then that's fine. I'm not the one taking the exam, and I'm not the one grading it. And I do post these replays on YouTube. So if for whatever reason you need to leave, don't worry. I will post these on YouTube today. Okay, so let's go ahead and get started. So I'm sure at this time you guys took the MCQ. You're already kind of tired. Some people are probably very discouraged, or some people are just pumped for the FRQ. We open it up. Oh man, brings back memories. So fun. Okay, so graphing calculator is required for this one. I'm going to have my TI-84 in front of me. And let's go ahead and solve it immediately. I mean, I think I posted a video about this. We see a table. You know they're going to ask us perhaps about a Riemann sum, maybe about the rate and change. Let's see. All right, so it looks like we have a table, and a customer at a gas station is pumping gasoline into a gas tank. The rate of flow of gasoline is modeled by the differentiable function f, where f of t is in gallons per second. So that's one thing to remember, that f of t is gallons per second. So that's a derivative. T is measured in seconds. Since pumping began, select the values for the f of t are given. Okay, so up on top it says like at 0 seconds, the gallons per second is 0. At 60 seconds, the rate of change or the gallons per second is 0.1. So here we go. Part A, using the correct unit to interpret the meaning of this integral 0 to 135. So the first thing that we're going to do is we're just going to define it. Well, this is just the integral 0 to 135. I said 0, but it's 60 to that. So when we solve that, that's just going to be the area underneath the curve. So we're going to definitely estimate this. Yes, thank you. It was 60. I said 0. My bad. And what this is going to represent at the very beginning, because this is a rate of change, this f of t is gallons per second. This just it's going to represent the gallons pumped between seconds 60 to 135. Some people might say like gallons pumped between, I was even thinking gallons pumped between 60, the first 65 seconds, but that's not correct. Okay, so that's the very first thing. You're gonna get a point for that by saying it was pumped between, or this is how many gallons it was pumped. Well, now what we're gonna do is we're gonna actually have to find that value using Riemann sums. Let me go ahead and draw out like a little rectangle here so we can have some space, and then we'll erase some stuff later on. All right, and then after that, they want us to find right Riemann sums from 60 to 135, and I think someone had already mentioned that they accidentally did 0 to 150 or 0 to 135. Such a bummer, but when we set this up, 60 to 135 of f of t, we're using right Riemann sum, so we start at 60. So the first interval, 60 to 90, that has a width of 30, times the right value, so 0.15, plus, now we're going to go to the next interval, 90 to 120. That's also 30 times 0.1. That's the right value, plus the next interval, which is going to be 0 to 135. And I think a lot of people are going to get comfortable thinking that everything is 30, and they're betting on seeing the 120, 135. That's just going to be an interval of 15. So we have to make sure that we write that correctly. Lily, let's talk about that. So I believe for number one, you're going to get a point for saying that it was gallons pumped between seconds 60 to 135, and then you're going to get a point for setting up the Riemann sum. And this is a calculator portion, so I have to assume that perhaps you're just going to have to simplify it. Okay? And again, don't be discouraged. If you feel like I'm putting the wrong answer, I could be incorrect. I am not the grader. I am not the one grading this exam, so there's a possibility that they have different ways that they want to grade this. So this is going to be 8.25 gallons. That's part A. Pretty simple. So I believe that's going to be 2 points. All right, awesome. So let's go to part B, guys. Oh, I love this one. When I saw it, I just smiled. Part B. It's asking, must there exist a value C between 60 and 120 such that f prime of C is equal to 0? I mean, come on. Easy. We're talking f prime of 0. We're trying to find some values. When I see that f prime of C is equal to 0, I'm thinking Rolle's theorem. So I believe this is only going to be a one point question. So because we say that f of 120, if you look at the table, is 0.1, f of 60 is also 0.1 on the table up on top. That's the definition of Rolle's theorem. The function is continuous and differentiable. The function is equal to each other at 60 and at 120. Therefore, by Rolle's theorem, yes, there exists a value such that f prime of c is equal to 0. That's it. Rolle's theorem. That's it. Not MVT. I don't even think you can get away with saying MVT. It has to be Rolle's theorem. Adam, I like that. That's kind of, I believe when I took the exam, I took it way back in like 2007. You can figure out my age there. I believe I wrote something like that because there's a rate of change. So I don't even think I specify Rolle's theorem, and I ended up getting a 5. So I would say, you know, if you explain it correctly, I think you're going to be fine. But definitely Rolle's theorem is going to give you that point automatically. Everything else is going to be up to the grader. Okay, let me go ahead and clear some stuff here. So now let's go to part C. They're saying that the rate of the flow of gasoline in gallons per second can be modeled by this. Whoops. I realized I don't have, there we go. Okay, so part C. The rate flow of gasoline in gallons per second, it's going to be G of T. Use this model to find the average rate of flow of the gasoline. So they want the average value of this function from the interval to 0 to 150. Average value. So we're going to use 1 over b minus a, integral from a to b of f of t dt. Actually, I'm going to change it to g of t, so we know that we're using that function. So we're going to set this up. It's going to be 1 over 150 minus 0, integral from 0 to 150 of the function that we have up on top. I'm not going to write it down. You already see it on top. So I believe you'll get a point for setting that up, and then they're going to want the actual value. So you're going to plug that into your calculator. You don't have to do any crazy work because this is a calculator portion. And this is where you have to make sure that you are on radian mode. And I'm just going to make sure of that. When I saw this, I think they're really trying to make sure that you don't mess up. If you notice, the cosine has double parentheses, so it's t over 120. Math Tutor S, what's up? How are you? Welcome, welcome. Okay, let me just set everything up. Hold on. I am on radio mode. I'm just making sure I set everything up correctly. Here's the thing. I'm just going to assume, I'm not even going to check my work there, but I'm just going to, I got 0.095. So that is the average value or the average rate of flow for the gasoline. We'll do the BC tomorrow. Joe, you asking for the average rate? Here's the thing. This is already the rate. This is the definition of the rate. So they're saying the rate is this function. So if you want to find the average rate, they're saying find the average of this value, which happens to be the rate. So you have to use the average value function. I'm over here just, entertaining some math nerds on the AB exam. So I calculated that incorrectly, or maybe not. We'll see. Again, if you see this on a replay, make sure that you are, gallons per second. I believe you are going to have to write those units. But again, if you see something wrong, let me know in the comments, or if you're watching a replay, let me know in the comments as well. Okay, so let's go ahead and do part D. Part D is asking, this is interesting. So we're using the rate or the model, the function g, interpret g prime of 140. So just keep in mind, g is already the rate of the flow. So when we take the derivative here, we're going to check whether it's increasing or decreasing. We've seen a couple of these questions. I believe I even talked about it in a couple videos. But we're going to take, all you have to do is you just have to write g prime of 40 is equal to, you can take the derivative on here, but I believe the way I would have written it is I would have done this. D over dt of this function, 500, cosine of t over 120 squared, and then I'm going to put t is equal to 140. And the reason why I'm doing that is because this is a calculator portion. I'm just going to use the derivative function on my calculator here. And now we're going to find it. So I'm going to go ahead and put the value here. So this is x over 500 times cosine of x over 120 and then close that, and then I'm going to put it at 140. And I get a value of negative 0.0049. Now, the value doesn't really matter, the fact that it's negative. And so we're going to say because g prime of 140 is less than 0, then the rate of flow is decreasing. That, I believe, you will get a point for that justification. So, Damon, can you say the rate of change of gallons flowing is changing at a negative? Yeah, I think that's a great way to put it. You're saying it is changing at a negative rate, or you can say it's decreasing. I think those are almost interchangeable. I believe you could use that. Okay, let's go on to the next one, guys. And again, if you see something or if you feel like letting me know in the comments, if you feel like I messed something up, that's fine. Again, I don't even think the answers are released. This is just how I did it. I saw this. I solved it within 15 minutes. And I just like to, keep the mystery going. I don't even want to look at the answer key. All right, let's go to number 2. People talked about the swimming one. So Steven swims, let me go ahead and just lower this a little bit. Okay, so Steven swims back and forth along a straight path in a 50-meter long pool for 90 seconds, and his velocity is modeled by that function that's there. T is measured in seconds, V of t is measured in meters per second. Perfect. So find all the times at which Steven changes direction. Well, if you change direction, that means the velocity is equal to 0. So you can kind of explain that. So what we're going to do is we're going to go ahead and graph this function. Because this is a graphing calculator problem, we're just going to graph it. These are always the worst, to be honest, just because you're spending so much time graphing these things, and you have to make sure you're putting the correct value. So to me, that's always the most nerve-wracking because I feel like I could make so many mistakes on this. Okay, so now I'm going to graph it real quick. And it's the first 90 seconds. Geez, okay, I have to change my parameter here. So let's go ahead and I got to change my window. And again, this is the annoying part of all this stuff. You got to change the window. 5. Okay, so on my graph, I see a couple times that it changes. So let's see. Oh my goodness, I believe even 0. You know what? I'm not even going to graph it. I'm actually going to use this is what I'm talking about. I hate the calculator portion because you're just spending so much time just plugging stuff in. Okay, so I'm just going to use another one. You're going to see why I'm doing this. So I'm just going to use the numerical, the equation solver on my calculator. And then I'm going to put sine of pi over 56x. Close that. Okay, I got x is equal to 48.35. I'm just going to double check my graph. Zoom window. I don't think it happens. The only time that I do see it happening is at 48.35. Let's see. Let's double check. Or no, I got 56. Okay, and this could be because my graph is just bad, but I got t is equal to 56 seconds. So again, the only time that it changes direction is when v of t is equal to 0. So I set this equation equal to 0, and I found the x-intercepts of the function. And so I believe that's all you have to do. So now we go to part B. Part B is asking for Steven's acceleration at time is equal to 60 seconds. Now, this is interesting. They say show your calculations and indicate the unit measure. So what you have to do is we have to say, okay, we're going to take we have our function, e to the negative 0.02 sine of pi over 56t. Though this is a calculator portion, they ask for the calculations. So we're going to have to actually use product rule here. So let's see. We are going to use, this is going to be negative 0.2. I'm taking the derivative of this function first, the 2.38 times e to the negative 0.2 times 2.38. And I get negative 0.0476 e to the negative 0.02t sine of pi 56t plus 2.38 e to the negative 0.02t, and then take the derivative of the sine function, which is cosine of pi over 56t times pi over 56. So this is the acceleration. They want to know what the acceleration is at 60 seconds. So we're going to have to plug in 60 into this function. And that is just a lot of fun. Let me go ahead and 0.02 times 60 seconds. And then I have sine of pi over 56 times 60 seconds. Close that. And then plus 2.38 e to the negative 0.02 times 60 seconds. And then cosine of pi over 56. The hardest, I mean, honestly, the hardest part of this whole thing is just making sure that you're plugging in everything correctly times pi over 56. Making sure I don't make any mistakes. And I got negative 0.036. Okay. So I just plugged in 60 into the function. Part of my calculation was making sure that I took the derivative and I used the product rule of these functions. Someone said, where did the e come out? I don't think it did. I used product rule and I took the derivative of the e function. So I multiplied the negative 0.02 to the outside. So this is what we get, and we have to make sure we give the right measurements, and that's going to be meters per second squared. Now they're asking, is Steven speeding up or slowing down? So the way we're going to have to do this is, remember, and I think I even mentioned a video, it's speeding up and slowing down. It's speeding up if the acceleration and velocity have the same sign, and it's going to be slowing down if they have the opposite sign. So it looks like the acceleration in this case is negative. We just got to figure out what the velocity will be at 60 seconds. So I'm going to plug that into my calculator. Times 60 sine pi over 56 times 60. And I get that this is negative 0.15 meters per second. So we're going to get a point for finding the acceleration, perhaps showing the steps. And then the next step that you have to say is, I'll put this in red, because both velocity at 60 and acceleration are 60 are negative. Steven. Adam, someone said, I didn't show the derivative calculations, but I got the same answer. You know what? It all depends on like how many steps you did, but from the way I interpreted this, they say show the setup for your calculations. So I took it as show how you're taking the derivative of this. So you could possibly get points. Let's just say you didn't show the steps, but you got the same answer. You would get a point for that. So worst case, you missed out on 1 point on this. But it seems like, you're getting the same answers as me. Alex, don't do that. You can totally take the class. Okay, so part C, find the distance. This is interesting. Find the distance between Steven's position at 20 seconds and the position at 80 seconds. So what they want for part C is they want the difference between s of 80 minus s of 20. That's the position function. And how are we going to do that? Well, we're going to take the derivative, or the integral of the velocity function, because according to the first fundamental theorem of calculus, this is the difference from the position of 20 seconds and 80 seconds. So from there, you can just go ahead and plug this into your calculator. 2.38 e to the negative 0.02 x, and then we have sine pi over 56 x. And then here we go. I get a total of 23.383 meters. I didn't round. I just truncated my answer, and I believe that's going to be correct. Jack, what's up, dude? Wait, are you JFP Cars? No way. Is this Jack? Jack who I saw, was it yesterday? If so, let's see, Adam. Hopefully the next answer is going to be 34. Anyway, if that's Jack who I'm thinking of, what's up, Jack? Hope you're doing well. All right, let's go to part D now. Find the total distance Steven swims over the time interval 0 to 90 seconds. So this is a little different because now they want the total distance. This is not displacement. Remember, total distance is the integral from 0 to 90 of the absolute value of the velocity function. Okay? So if we do the absolute value, go back to your calculator. We're going to put that. Let's see. Someone said they hope that it's going to be 34. Adam, let's hope it's 34 meters. We'll find out. Hold on. Give me 1 second. I'm just putting the absolute value of this whole thing, 2.38 e to the negative 0.02 x, and then sine of pi over 56. Let's go. Moment of truth. Adam, moment of truth. It's calculating on my end. Oh, bro. I got 62.164 meters. Did everyone get a different answer? Yeah, 62.164. Adam, how did you get? Did you do, you know what? I think you must have done 20 to, and this just goes, this just goes to show that the AP Calc, they love to trick you on little dumb technicalities, to be honest. Adam, I got 39. I assumed you did the integral from 20 to 80. But yeah, the answer was going to be 62.164. So I believe you will get a point for setting up the equation and then, so setting up the integral and then getting the answer. Or perhaps it's 1 point and you get half a point for one. All right, guys. But again, don't get discouraged. It's all good. It's all good. You'd be very surprised what the average was going to be. I've seen problems where the mean, the mean for the entire problem was like 1.2 points, meaning that everyone got everything wrong. Oh, you didn't do the absolute value. Listen, all good. You did displacement, but that's fine. The milk problem. Nothing to worry about. Listen, and I think I mentioned this as well on previous TikToks. So if you're watching this in the future, if you're watching this for next year's AP exam, know that when you see a slow field, I'm thinking differential equations. I'm thinking separation of variables. So they tell us this bogus equation where they tell us that, what is it? The rate of degrees, the differential equation just represents the rate of degrees. Okay, so then they give you the slow field, and they want you to find the slow field starting from the point 0, 5. So even if I zoom in, maybe if I do this. Okay, so this is part A, guys. You're going to graph your line starting at 0.5 or 0, 5, and you're just going to follow that slow field. Let it guide you. Boom. You get a point for that. That's it. This was this was your 13th reason. That's funny. Honestly, this was fun, and I hope that the students I saw the night before the exam thought about me when they did this problem, because we had struggled on this specific problem 2 times in a row. But anyway, that's a slow field for you. I'm going to go ahead and erase this. It looks good so far. Okay, so again, they give you that entire equation, but that's okay. Now what I'm going to do is I'm going to kind of cover this so we have enough space. I'm going to put like a big rectangle here so we can have enough space. But we're going to do part B. So part B, they want the equation of the tangent line at t is equal to 0. Okay, so they want at t is equal to 0. And that don't forget that when t is equal to 0, the temperature is going to be 5 degrees. So M is going to be 5. Okay? So they want that equation. So what we need to do is we want y minus y1 is equal to m times x minus x1. Now, I'm assuming people might get confused with the m, but the m is the actual slope. Here, the 5 represents the y1, and the x1 represents the 0. So my equation will look like this so far. Y minus 5 equals m times x minus 0. So we need to find m. Remember, m is the slope. Slope at 0, 5. So the slope is going to be this equation that they gave us. So the slope is this equation, and that's 1/4 times 40 minus m. And so we just plug in the necessary values. And this is the confusing part. A lot of people will plug in 0 for m, but that's not true. Remember that this is 5. So we get 1/4 times 35. So 35 over 4 is our answer. So we're going to get a point for this. Y minus 5 is equal to 35 over 4. times x minus 0. That's 1 point, because that's the equation of the tangent line. And then now what they want is they want us to estimate m of 2. So all we have to do now is plug in 2 in for the x value. Now, I don't, did I see this in the comments? Let's see. The only thing about this is that my variables are a little off. You know, I don't think that's going to be a big issue, but it should look like this so far. M minus 5 is equal to 35 over 4 times t minus 0. So now, because we want to estimate the value at t is equal to 2, we're going to plug in 2 for the t. So we got 35 over 4 times 2 minus 0. And so now we got m minus 5 is equal to, what is this, 35 over 2, and then add the 5 to the other side. So 35 over 2 plus 5. And I don't even think you have to simplify this because there's no variables whatsoever. I'm just going to leave it like that. Oh, and then one thing, obviously, degrees Celsius. So we're just going to put degrees Celsius, and we're good. All right, let me know in the comments. What do we think? Did we get that right? I'm going to do FRQ 5 and 6. Those are coming up. And 5 and 6. Oh, my goodness. Good stuff. All right. It's coming up. And don't forget, guys, if you guys have to leave, I do post the replays on YouTube so you guys can watch this. I'm sure a lot of people have already solved it, but it's just good to go on here. Awesome. Okay, let's go ahead and do part C. Again, I'm going to put more of a little rectangle out here just so we have enough space to do all the work. But what they want is they want us to find the second derivative, and they want and then they want us to tell us whether this is going to be an over or an underestimate. So first, we're going to go ahead and write our derivative function. Let me position myself a little better. I was leaning back. So dm over dt is equal to 1 over 4 times 40 minus m. All right, let's get cracking. Let's go ahead and take the derivative of the left side. D squared m over dt squared is equal to 1/4. This is just going to be 1/4 times negative 1 times dm over t. Now, how did I do that? The first value is just a constant, and then I just took the derivative on the inside. The derivative on the inside is negative 1, but then I just need to multiply by dm over dt. And don't forget, dm over dt was the original function. Okay? So what did we, oh shoot, what did I get for, I think it was like 35 over 2 plus 5. So I guess I had to kind of like, the value for part B, m of 2, was equal to this value up on top, 35 over 2 plus 5. I guess I can maybe simplify. I didn't think I had to. That's going to be 45 over 2. And now what they want us to do is they want us to plug that in to our second derivative. So here we go. If we're going to plug in that 45 over 2 in for the m, so we have negative 1/4 times 1/4 times 40 minus 45 over 2. Okay, we can kind of simplify this if we want to. But what's going to happen is we're going to have negative 1 over 16 times 80 over 2 minus 45. It's important that you kind of, we need to simplify this because we want to know if this is going to be a positive value or a negative value. And we get negative 1 over 16 times, this is going to be 35 over 2. Okay, which means it's negative. So the one thing, because the second derivative is negative, this is going to be an overestimate. So then our answer, give your reason for your answer. Because the second derivative is negative, it is going to be an overestimate. All right, Chad, let's go ahead and do part D. This wasn't even that hard, in my opinion, it's just time consuming. But part D, another rectangle that I'm going to draw. Okay, so now we actually got to find the original function using that initial condition. So we go back to dm over dt is equal to 1/4 times 40 minus m. We're going to use separation of variables. So let's go ahead and move the dt to the other side. So we're multiplying dt to the other side. And at the same time, we're going to divide by 40 over m. So we have dm over 40 minus m is equal to 1/4 dt. And now we can go ahead and take the integral. The integral on the left side, you got to be very careful. Technically, you have to use a u substitution. And the answer is negative natural log of 40 minus m. The reason why is because when we use u substitution, 40 minus m, the derivative of that is negative 1. And this is going to be 1/4 t. And don't forget, now we add the plus c. All right. At this point, I'm going to go ahead and plug in the initial condition. T is equal to 0. The m is equal to 5. So I have negative natural log of 40 minus the 5 is equal to 1/4 times the 0 plus c. Okay. So we have negative natural log of 35 is equal to c. Easy enough. Now we can go ahead and plug that into our equation. Let's move this up to the top. So now we have negative natural log of 40 minus m is equal to 1/4 t minus natural log of 35. I hope that fits on the screen. Yes. Let's go ahead and multiply everything by a negative. So we have natural log of 40 minus m is equal to natural log of 35 minus 1/4 t. I just switched them out because one of them became positive, the other became negative. And now we can go ahead and take the e to both sides. E that sucker. And so now we're left with 40 minus m is equal to. Now this one's tricky. You can leave your answer e to the power of the whole thing, but I'm just going to do this. E to the natural log of 35 times e to the natural log of negative 1/4 t. You don't have to do this, but I just saw it because I saw that opportunity for the e. Okay, so now we have negative 40 minus m, or 40 minus m, I'm sorry. And then that e to the ln 35 just becomes 35, e to the negative 1/4 t. And now we can go ahead and subtract the 40. Negative m is equal to 35 e to the negative 1/4 t minus 40, and then divide by a negative. And here we go. Negative 35 e to the negative 1/4 t plus 40. That is our initial condition, or that is our original function. Let's go, your son, boy 2. Caden, I literally, someone commented on my one of my videos that it was out. I literally Googled 2023 AP Calculus AB FRQ. I wish I can say I have some crazy methods here, but that was it. All right, here we go. We're almost done. Actually, halfway. Let me erase everything. I'm sorry. There we go. Oh, guys, this was easy, but one of the things, this was just time consuming. Okay, here we go. And by the way, I know people were requesting the BC. If that shows up, or if I find it, I'm going to go live tomorrow and cover that. Sorry, it's the coffee. Okay, big thing here. They give us the graph of f prime. No surprise. You see this, you're like, oh, they're going to ask me for a stupid area question. Perhaps they're going to ask me about the derivative of the function. Nothing crazy to, it's just nothing crazy. Part C is going to be really easy. I'm already thinking part C is definitely going to be a L'Hopital's rule. I think I haven't mentioned that. I mentioned that in one of my videos. So number 4, here we go. We're given the derivative of the function on the interval negative 2 to 8. And then we have one condition, f of 2 is equal to 1. That's going to be huge. The graph of f prime is given to us. So now let's go to number 2. Does f have a relative minimum, a relative maximum, or neither at 6? Neither. Okay, so at 6, we know for sure that f prime of 6 is equal to 0 because that is the graph of the function. But if you notice, to the right of 6, the derivative is positive, and to the left of 6, the derivative is also positive. So a lot of people are going to say this is a minimum, but this is the graph of the function. So they are both positive. So therefore, it's neither. And so for A, we say because f prime of x is greater than 0, to the left and right of 6, f has no min or max at x equals 6. That's it. All right, that was A. That easy. And now we go to part B. On what open interval, if any, is f concave down? Well, don't forget, and this is what you have to kind of explain. Concave down means when the second derivative is equal to 0. That's concave down. In other words, if we're talking about the graph of the function, concave down means when the derivative is decreasing. So all we have to do is look at the function, because that's the graph of f prime, and you'll notice that it is decreasing on this interval and this interval. So that's one thing you could say. Because the function or the derivative is decreasing from -2 to 0, union 4 to 6, that is where it's concave down. That is where f is concave down. Okay, part of the things that they want you to explain your reasoning is you just have to say it's concave down when the second derivative is a negative, and it's that means when the derivative is decreasing. That's it. Easy. Part D was the only time-consuming one, but part C, here we go. So find the value of the limit. Okay, a lot of people said like, oh, well, you have to make sure you use direct substitution. You technically do have to. So we're going to write the limit first. X squared minus 5x plus 6. And we're going to use direct substitution. So we're going to plug in the 2. So 6f of 2 minus 3 times 2 all over 2 squared. 2 squared minus 5 times 2 plus 6. All right, here we go. Remember, f of 2, they gave that to us. It was one of the conditions up on top. F of 2 is equal to 1. So what we have is 6 minus 6 over, and then on the bottom, we're just going to simplify this. This is going to be all 0 because it's 4 minus 10 plus 6. So we got 0 over 0, a beautiful indeterminate form, so we have to go ahead and use L'Hopital's rule. So far, it doesn't exist. I believe you're going to have to show that it's 0 over 0, and then from there, I'm going to go ahead and take the derivative. I need space on here, so I'm just going to go ahead and erase my work. We already know that it's going to be indeterminate. I'm going to try to post the videos after this. I believe once I stop the live, it goes on my portal. It's there for me to download, and then I'll put it on YouTube, okay? Okay, so like I said, we're going to apply L'Hopital's, the hospital rule. Let's go. So we're going to go ahead and take the derivative of the top, and that's going to be 6f prime of x minus 3 over 2x minus 5. And now we're going to go ahead and plug in the 2 again. 6f prime of 2 minus 3 over 2 times 2 minus 5. All right, on the bottom, I'm just going to have 4 minus 5. That's negative 1. On the top, 6 times f prime of 2. We can find f prime of 2. We just have to go to our graph. And f prime of 2 is 0. I circled that in red there. So I have 0 minus 3. So the answer is just 3. Who got it right? Let me know in the chat. Let's go. And again, if you're seeing this in the future, if you see a limit problem on the FRQ, it's because they want you to use direct substitution, and then they want you to find the limit using L'Hopital's rule. Chris, let's go. Angie, yes. Beautiful. All right, let's go to part D. This is the time-consuming one because they want to find the absolute minimum on the interval -2 to 8. So one of the unfortunate parts that we have to do is we have to test -2 and 8 and then see if there's any minimums. So remember, minimums occur. Minimums mean that f prime goes from negative to positive. Okay? So it has to alternate. So if you're looking at the function, the derivative here, it's above the x-axis, so this is positive, and then it goes negative. So technically, we do have a critical point, but -1 is a maximum. So we don't want that one. So then we're going to go to 2. Or right as we're getting... Uh-oh. Let me know if I lost you guys. Shit. Let me know if I'm still here. I hope I am. I'm getting like a message that I lost signal, but let me know if I'm here. Comment anything. You can just type whatever. I just want to make sure that I didn't lose you guys. So like I mentioned, -1 is a maximum, 2 is a minimum, 6 is neither. So we're not even going to use that. Awesome. Thank you. Let's go. You guys are the best. Okay. So the only one that the only one that we really need to test is going to be 2 because that's going to be a minimum. So we need to test f of 2, f of -2, and then f of 8. Okay? Luckily for us, they already told us that f of 2 is equal to 1. So we know f of 2 is going to equal to 1. Now, how do we test f of negative 2? Because again, this is the absolute minimum. Well, we're going to use the net change formula. So first we're going to start off with f of negative 2. Let me just erase some of the things that I have up here. So we want to find f of negative 2. So we're going to take the integral from negative 2 to 2 of the derivative. Why? Because this is equal to f of 2 minus f of negative 2. This is the net change formula. This is the first fundamental theorem of calculus. Now, on the right side, f of 2 is 1. We're trying to find f of negative 2. And on the left side, the integral from negative 2 to 2 is literally just the area underneath the curve from negative 2 to 2. Now, how are we going to find that? Well, you can go ahead and take the area of all these triangles. But if you notice from negative 2 to 0, these two triangles are the same. One's on the top, one's on the bottom. So that's just going to be 0. We're not even going to worry about that. So all we really need to do is find the remaining area, and that's that one triangle. So this triangle here, remember, it's a triangle, so the area is 1/2. The base is going to be 2, and the height is going to be negative 2. So this is going to be negative 2. And so now what we have, down on the bottom, we have our area, negative 2. And so what we can do is we can subtract the 1 to the other side, and we get negative 3 is equal to negative f of negative 2. And so that is going to tell us that f of negative 2 is equal to 3. I'm just going to put that up on the left side. All right. What's up, E? Now let's go ahead and find the last one, f of 8. And so remember, we need to find, we're just testing the values because they want the absolute minimum value. And so we're going to do f of 8. We're going to take the integral from negative 2 to 8 of f of, actually not from negative 2 to 8, from 2 to 8 of the derivative function. And that, according to the first fundamental theorem of calculus, that's f of 8 minus f of 2. Okay, we already know f of 2. That's going to be 1 that was given to us. So we have f of 8 minus 1. And then we just need to find the area. Okay. We need to find the area from 2 to 8. So from 2 to 8, we have the first triangle from 2 to 4. That's an area of 1/2, 2 times 2. So that's just going to be 2. And then we have the area of that little like circle here, or like the remaining portions of a circle. Now, how do we find that? We unfortunately have to take the area of the rectangle and then subtract the area of that like half circle. So the area of the rectangle is it looks like it's 4 by 2. So 4 times 2, so it's 8. And then we're going to subtract the area of that half circle. So that's going to be pi 2 squared divided by 2. So 2 pi. So then the area is 8 minus 2 pi. So down below we have 2 plus 8 minus 2 pi, and then is equal to f of 8 minus 1. So this is 10 minus 2 pi is equal to f of 8 minus 1. We could bring the 1 to the other side, so we have 11 minus 2 pi is equal to f of 8. Okay, so this is interesting. 11 minus 2 pi. 2 pi is around 6 point something. So then f of 8 is just going to be 11.2 pi, which is approximately like 5 or something like that. Okay, they want the minimum value. That's just going to be 2. So at the very end, they wanted us to show all the work. As you can see, part D was just so freaking time consuming. And I could totally understand. You guys are all burnt out. After this, you're like, screw this. This is just, I don't even want to do this anymore. Okay, but hopefully we're looking good. Hopefully you thought of all the other problems and you're like, okay, so far so good. You got your points here and there. But part D was definitely the most time consuming one. And again, if I made a mistake, let me know in the comments or let me know in the replays. Y'all know I'm notorious for making some mistakes, especially when I'm going live. I mean, it happens. It happens. That's what math is about. Guys, this one, I saw this. I'm like, they really want to give you guys some free points. Okay, so they give us this crazy table, and then they tell us that H is equal to F composite G. So they want H prime of 7. All right, so remember, if H is equal to F G 7, so then H prime, according to the chain rule, is going to be f prime of g of x times the derivative of what's inside, which is g prime of x. And now we just have to plug in 7. H prime of 7 is equal to f prime of g of 7 times g prime of 7. So the first thing that we're going to do is we're going to find g of 7. G of 7, if I circle that, that's 0. So now we have f prime of 0 times, let's just go ahead and find g prime of 7. Up on the graph or on the table, I have 8. So that's my g prime of 7. And then at the very end, I can go ahead and find f prime of 0. Yeah, you guys can see that on the screen now. F prime of 0 is going to be 3 halves. So I got 3 halves times 8, which is just going to be 12. Let me know in the chat if you guys got this one. This was your weakness? Oh, I'm so sorry, Tara. And honestly, it's like when you see it now, you're like, shoot, I feel like it's so easy. But I can totally understand. Everyone has their weaknesses. Everyone has their strengths. This is just, it happens. All right, so that's H. Let me go ahead and erase my work. And now let's go to part B. So we have the differentiable function. So k prime of x is equal to this f of x to the power of 2 times g of x. Is a graph of k concave up or concave down at x is equal to 4? Well, keep in mind, they already tell us k prime. K prime is equal to this weird looking function. And now they want is it concave up or concave down? Well, we just need to find the second derivative, aka the derivative of the function that we are given. So we're going to use product rule. The first thing is we're going to take the derivative of the first function. And that you have to use chain rule. So I have 2 times f of x to the power of 1. I'm not going to show the power of 1 because people are going to get confused and think it's a prime. Times f prime of x according to chain rule. And then we still have that second function. Plus f of x to the power of 2 g prime of x. And now all we have to do is go ahead and plug in the 4. So k double prime of 4 equals 2 f of 4 times f prime of 4 g of 4 plus yada yada yada. Y'all can see that. Isn't this fun? Isn't this just like easy now that you see it? All right, so let's continue. So f of 4 is going to be 4, if you look up on the graph, times, or not on the graph, on the table. F prime of 4 is 3, so we have times 3. G prime of 4 is going to be negative 3, plus f of 4, we already established was 4, so we're going to square that, times g prime of 4, which is going to be 2. Yo! Okay, let's just simplify this. I think we can probably leave it like this, but I'm just going to simplify a little bit. So let's see, 2 times 4 is 8 times negative 9, so negative 72, and then plus 32, and I believe that's negative 40. Oh, so that's the thing. We found that this is negative 40. The question was asking whether it's concave up or concave down, and we say because the derivative is negative, we said it's going to be concave down. Tristan, I already did the milk one, yes, and I will post the replay on this on my YouTube, but yes, I did the milk one. You're late to the party. Now you need some milk. Yo, negative 72 plus 32. If I did my math wrong, I know someone say concave up, but I think it's concave down. So again, you have to state this because the function or the derivative, not the derivative, the second derivative is less than 0, it is concave down at x is equal to 4. Here we go. This is going to start getting real fun. Here we go, part C. So we're given this function 5x cubed plus 0, the integral from 0x f prime of t. I'm already thinking you either want me to use a second fundamental theorem of calculus or the first fundamental theorem of calculus. Okay? I will do differential equations and linear equations later on. Today we're just covering this exam. I am not smart at all. Listen, I am just an entertainer, man. Guys, please continue to follow me. I am going to keep going live. This is what I do. I don't care. Like, I just want to have fun with you guys. This is what we're going to be doing. And please continue following me because I'm going to be going live. And pretty soon I'm going to have a whiteboard in the back. And we're going to be switching cameras. We're going to go from sitting down to standing up. We're going to get wild with this stuff. Anyway, let's go to part C. So they give us this function. And we should already start thinking because we have this integral. God, they're going to give us a first fundamental theorem of calculus or a second one. All they want us to do is find m of 2. So if we're given the function 5x cubed plus 0 to the x f prime of t, m of 2. So we just have to plug in the 2 for the x. Okay, so this is where I plugged in my 2's. The first one, 5 times 2 to the power of 3, that's just 5 times 8. So that's going to be 40. And then look at this. You're like, I don't even have an integral. Where's my function? Well, this is the integral of f prime. So this is just going to be the first fundamental theorem of calculus. This is equal to f of 2 minus f of 0. So we have 40 plus, let's go ahead and figure out f of 2. That's 7 minus f of 0. That's 10. So this is 40 minus 3, so 37. Not bad, huh? I'm going to start doing, I think, I've been focusing a lot on calculus, but I will start doing some differential equations and probably some physics questions. That's being requested a lot on Instagram, so I think we should do that. Let's go. I'm so pumped. And for those that felt like they got it incorrect, do not worry. I'm hoping that you showed enough steps, okay? Don't get discouraged. Listen, it's over and done with. You guys just remember how fortunate you guys are to take this exam. This is a rite of passage. To be honest, I mean, to go back and say, I took the AP exam, I didn't do well, or I did extremely well, that's a good thing, all right? You're out there. You took the exam. That's what matters. So part D, is the function m defined in part C increasing or decreasing? So we need to take the derivative because they're asking about whether it's increasing or decreasing. So we're going to take the derivative. Don't forget, we have 5x cubed plus 0 to x of f prime of t dt. This is where you got to be careful. So we're going to take the derivative. The first part is just 15x squared. And then the second part, we're just going to implement second fundamental theorem of calculus, and that's just f prime of x. So they just want the value at 2, so 15 times 2 squared plus f prime of 2. The first term, 15 times 4, that's 60, plus f prime of 2. Looking at the table, that's going to be negative 8. So then we get a value of 52. So because m prime of 2 is greater than 0, it is increasing. Excuse my bad writing. When I write in the corner there, my pencil just goes crazy. All right, let me know how we did in part D. I know people were looking at the question there, and then you're like, what the fuck? But it's okay, guys. A good 10 seconds in part D. So if everyone was getting that incorrect, I don't blame you. Calc 3 is really fun. So if you have a strong background in Calc 1 and Calc 2, Calc 3 is going to be a breeze. All right, let's talk about part D. Let's go. All right, so part A, they give us the derivative, or they give us the original function. I'm sorry. Oh, this is a perfect opportunity. I love when they leave us with all this space. Look at that. So now, part A, they just want us to take the derivative. That is implicit differentiation. So we have implicit differentiation in our minds. So on the left side, we're using product rule. So we take the derivative of 6x, so 6y, plus 6x times, technically the derivative of y is 1, but then because we're doing implicit differentiation, we have to do dy over dx, is equal to the derivative of 2, which is 0, plus 3y squared dy over dx. Okay? I'm going to go ahead and subtract the 6x dy dx to the other side. So I have 3y squared dy dx minus 6x dy dx. And let's go ahead and factor out the dy dx from the other side. So dy dx is equal to, not dy dx, parentheses 3y squared minus 6x. And what do? We divide the 3y squared minus 6 to the other side. 3y squared minus 6x over 3y squared minus 6x. And what do we know? The derivative is equal to 6y over 3y squared minus 6x. Excuse my bad writing there. What the Why is this incorrect? Oh, I'm so dumb because I'm like, this doesn't look like A. So on the bottom, this looks pretty much the same thing. The one thing that we notice is that there's a difference in the constants. So on the bottom, let's go ahead and factor out a 3. So y squared minus 2x. And what we can do is the 6 and the 3 can cancel out, and then we only have a 2 on top. So at the end, our answer is 2y over y squared minus 2x. Had me on the first half, not going to lie. No! Oh, you guys definitely knew this. You close your booklet. It's right. I would have done the same thing if I was taking the test and if I was confused. Sometimes you just get frustrated with these questions. You're like, dude, get out of here, man. I don't even want this. All right, guys, let's go to part B. So find the coordinate of the point on the curve at which the line tangent to the curve is horizontal. Horizontal tangent, that just means the derivative is equal to 0. So what we're going to do is we're going to set this equation equal to 0. So that just means the top has to be equal to 0. We're going to talk about the bottom later on. This is the last FRQ, Angie, yes. And again, if you guys are just coming in later or late, don't worry. I did all 6 problems. The replay will be posted on YouTube, so you guys can watch it later on. Okay, like I mentioned, horizontal tangent is when the top is equal to 0. So 2y is equal to 0, meaning y is equal to 0. But I don't even think we're done because they want find the coordinate of the point on the curve. We got to find if y is equal to 0. This is where I thought I got it correct. I think I'm going to get it incorrect, but I'm just going to assume because we found y is equal to 0. That's when the function has a horizontal tangent, or so we think. So then when you plug in 0, because you're looking for the coordinate, you're going to plug it into the original function. So this is my original function, 6xy is equal to 2 plus y cubed. We're going to plug in 0 into everything, and then maybe you're already seeing what's going to happen. This is going to become 0 on the left side is equal to 2. That can't happen. So this work right here, we say no point or no horizontal. Part B, in my opinion, if I get it wrong or if someone wants to argue something else, let me know. But let's go to part C. Find the coordinates where there is a vertical tangent. So that just means vertical tangent. Same thing, we're going to take the derivative, but we're going to make sure we set the bottom equal to 0 because when you have a bottom, your slope is undefined. And that means that if I was to, for example, draw, I don't know, a graph, let's just say it's a circle. If I have a vertical tangent, my slope is undefined. So that means that this slope here has to have a denominator equal to 0. So that just means that y squared is equal to 2x. And that just means that y is equal to plus or minus root 2x. Okay. Geez, when I did this, I'm like, oh, we're just going to set the top and the bottom equal to 0, but I think this is why it gets confusing. So I found my y value. Let's go ahead and plug that into the top up here. So we're going to plug it into the 6xy is equal to 2 plus y cubed. And then we have 6x times, let's just first focus on the positive, is equal to 2. So now what we have over here, it's a little weird. We have 6x root 2x is equal to 2 plus. Now, you got to be very careful with this. Technically, this is 8x cubed. Okay? That's how it looks like right now. But if I simplify this, what we have is we have 6x root 2x is equal to 2 plus 2x root 2x. The reason being is because the root 8 turns into a 2 root 2, and the x cubed, there's 2x squared, or there's an x squared in there, so we can take that out. And now this is kind of nice because I can go ahead and subtract the 2x root 2x to the other side. And so now we're left with 4x root 2x is equal to 2. I guess we can divide the 4 and get x root 2x is equal to 1/2. Bro, this is just ugly. So what? Square everything? Oh my gosh. Okay, so this becomes x squared times 2x is equal to 1 over 4. Let me make this a little smaller. I think it's actually making sense now, kind of. I'm going to make this smaller because I want to make sure I show all the work. Actually, I'm not going to be able to. I'm going to put my work up on top. Bear with me. I'm going to put it right here so it fits. So I divide the 2 to the other side, and I get x cubed is equal to 1 over 8. X is equal to 1/2. We found the x value. X is equal to 1/2. Yes. Yes. So I saw for x was equal to 1/2. And then I need to find the y value for that. So what we need to do is we need to plug it into my y value, which is that equation up here, or the equation that I just circled in blue. So I got y is equal to plus or minus, y is equal to plus or minus root, and then we have the 2 times 1/2, and that just becomes 1. So we have 1/2, 1, and I believe if I do the negative 1/2, I think we're still going to get the same answer. But this is one of the answers. Yeah, I solve for x here. Oh, I see what you did, Kishan. Yes, you can solve. I did solve for x. Anyway, this was the coordinate. Part B was, or part C was definitely confusing. Let me talk about part D, okay? Because I'm almost out of time, unfortunately, so I just want to cover this one. Let me clear this. Part D was a little confusing because they tell you that the point is 1/2 comma negative 2. Its horizontal position is increasing at dx over dt is equal to 2/3. They just all of a sudden introduced the dt. What's going on here? But they want the value of dy dt. So again, this one stunned me a little bit because I'm like, what? Where is my dx dt? What's going on? Well, what we have to do here is we have to take the derivative of this in terms of t. So think of it like a related rates. So what we're going to do here is we're going to go ahead, and we're going to use product rule. So we're going to start off by taking the derivative of 6x. So that's 6, but then now I'm including that dx dt because this is a related rates type problem. Plus 6x times 1 for the derivative of y, dy dt, equals, on the right side, the derivative of 2 is 0, plus 3y squared dy dt. Okay, let's go ahead and plug in the stuff that we do know. They told us the coordinates, 1/2 comma negative 2, and they told us that dx dt is equal to 2/3. So you're going to have 6 times 2/3 for the dx dt times the negative 2 for the y, plus 6 times 1/2 for the x, and then dy dt is what we're trying to find, equals 3 times negative 2 squared dy dt. Okay, let's go ahead and simplify this a little bit. What do we got? This is going to be negative 8 for that 6 times 2/3 times negative 2. You got to kind of think about your fractions there. Plus 3 dy dt equals, and then on the right side we have 3 times negative 2 squared. That's 12 dy dt. So we can go ahead and subtract the 3 dy dt to the other side. That gives us negative 8 is equal to 9 dy dt. Moment of truth, negative 8 over 9. Whoops, let me make this a little neater. Is equal to dy dt. Oh no, how'd you mess up? Anyway, that was the last problem in part D, or in question 6. That one was definitely confusing, and honestly, I think I missed some work in part C. So if you guys want to comment on that, let me know here, or let me know in the replays if you guys are watching this on YouTube, or in the future in 2024, because we are going to continue doing these types of problems and getting the next generation of math nerds ready for the AP exam. Let's go, Angie. Yes. Okay. So this was it. I'm going to try to find the FRQ for the BC exam and possibly go live tomorrow so we can talk about it if you guys took that exam. But before I leave, I would love to hear in the comments, how do we feel? Do we feel like we did really well? Do we feel like, okay, I'm screwed? If so, it doesn't matter. It's over and done with. We move on, okay? There's honor in not doing well because we get back up and we practice the problems again. Okay, only got A and B, A and D right, and that's fine. Don't forget, I think this one was really tough that I almost guarantee that it is going to have a very, very low score. So, for example, let's just say the mean was like, the majority of people only got a 2 or only got 2 points in this problem. That could be considered a 3 or a 4. Hoping they pity you. Well, I hope you guys drew some messages on there like, please, sir, please help me out. Please, I promise, I studied. Melvin, I don't know. Typically, they only post one, and then some people have it like in the College Board portal. So if you guys have that, or if your teachers have given you that, look into that. And if that's the case, shoot, go on the Discord, go on my Instagram, like DM me that stuff because please, I want to know. I'm so proud of you guys. You guys are on here discussing the problems. And if you're watching the replay, I would love to know how you felt about it. And if I made any mistakes or if you would have solved it differently, please let me know. Again, I am not a test grader. I'm not the proctor. So what I say is not really, what you're going to get graded on. So definitely consult with like your calc teacher because typically they do have or like they're given directions on like what the types of points. But again, I've seen these types of problems. I've seen the answers so many times that you can see what type of points or how many points you're going to get for that type of question. Yeah. Anyway, y'all, I'm going to get going. I actually thought this was going to take longer than I imagined, but not bad. I think we were live for an hour and 11 minutes. Nice. I don't know how long the AP exam was, so let's just assume. So 1 hour for 4 questions and then 30 minutes. So 90 minutes. We have 90 minutes for all 6, and we did them all within 90 minutes. Let's go. Let's go. Okay. You're confident you got a 4 because you messed up on the multiple choice. That always sucks. Like, I'm sure there were some problems in the multiple choice, and you're going to come back and think, screw it. Like, I could have done so much better. But a 4 is still extremely good. Hey, I'm hoping that they let everyone slide out with a 3. I don't even know. To be honest, I don't even know how I got a 5 on this. I just sat there and I started like, scribbling what I can, and then all of a sudden the scores came out, and it turns out I guess I knew the material. That's what a lot of people said, Angie, that the calculator portion of the MCQ was definitely confusing. If anything, I think that was the hardest one. Yeah. All right, y'all. I'm going to head out, but I hope you guys enjoyed. Again, if you're watching the replay, don't forget to comment and let me know if I made any mistakes. And please follow me on here because the more I go live, the more I can do this and continuing entertaining you guys. Because that's what we want to do, because math is fun. It's just what it is. I know some people use it for educational purposes, but this is entertainment purposes only, baby. Tara, I'm kind of bummed that they didn't do one. I know it can be a little time consuming, but I mean, you've done it so many times when it comes to area between two curves and when it comes to like the disc and washer method that I feel like that would have been easy points. But I'm surprised too, because typically they do give it to you. All right, everyone. I hope you all have a great day. Again, don't be too bummed out. Don't worry about it. It's over and done with. We move on. I'm going to probably go live tomorrow just reviewing either the Calc BC exam if I find it. If not, I'll do some like integration B stuff. I think it'll be really fun. But if I don't see you, hope to see you on the next live, maybe next week or the week after. Continue to follow me here on TikTok, on Instagram. I'm also on YouTube, and I have a website. So I'll see y'all real soon. Oh, interesting. Before I leave, Angie, she said, my teacher told me they're trying to move it into the MCQ. Oh, that'll be really interesting. Okay. Yeah, if you start seeing patterns or if you start taking tests from different years, like 1980 and on, you start seeing the changes. The multiple choice can be really difficult, and then the free response is easier, and this kind of alternates. Yeah, who knows? Who knows? Exactly. All right, everyone. Hope you have a great day. See you real soon. Yes, AP pre-cal coming out next year. That's going to be really fun. More review for that, all you math nerds. All right, bye everyone. See ya.